So, good morning, everyone. So, today I'm going to start a subject that is strength of material. Before that, I just want to tell you what is the weightage of this subject in the GATE exam. The weightage of the strength of material is around 7 to 9 marks. 7 to 9 marks. And the application of this subject is the machine design. Okay. So, what are the important topic if I will talk about the strength of material? So, the questions they are framing based on the how you will calculate the internal forces. That means the question based on internal force, internal force in any member. Second, the question based on the thermal stresses. Then question based on the elastic constant and how you will calculate the elongation of bar. Elongation of bar. Okay. So these are the important topic from the first chapter. Okay. Then I will move to the SFD and BMD. So if I will start this strength of material, you already know the basic terminology we are using in strength of material is stress. What is stress? Stress is nothing but the internal resisting force per unit area. Internal resisting force per unit area. For example, there is a bar of circular cross section. If you are applying some equal and opposite tensile load, then what will happen? This particular bar is made up of some material. So whatever the external load which you are applying, okay, so this bar is made up of infinite number of particles. So if you take a cross section here, if you take a cross section here, let us suppose the left hand side portion. Now each and every individual particle will apply some resisting force. Let us suppose this is the resisting force by the small particle df. So if you divide this small particle df with their small area dA, that is nothing but the stress. That is nothing but the stress. So this is based because of the this is nothing but because of the small only one particle. But you know that this rod is made up of infinite number of particles. So each and every particle will resist the load. So if each and every particle is resisting this force, whatever you are applying externally, then if you take the summation, then you will get the total force, total internal resisting force. And if you divide with the total area, then you will get the stress. Then you will get the stress. And in case of strength of material, we used to consider a deformable body. Okay. In case of engineering mechanics, we are dealing with the rigid body. And in case of strength of material, we are dealing with the deformable. Deformable means when you are applying some tensile load, then this body is going to deform. That means let us suppose the initial length is L and the diameter is D naught. So once you are applying the length, once you are applying the load, then length value will be increased. Okay. So the diameter value will be decreased because there is no material which is going out from this material rod. That means the volume should be constant. So the first terminology is nothing but the stress. Now, the second thing is how you will calculate the internal forces. Okay. So mostly they are framing the question based on the internal forces. They can ask you the stress also. Once you understood how to calculate force, if you divide with area, you will get the stress. Okay. So now I'm going to discuss the this question. But before that, one question was asked in the GATE 2013. Very simple problem. A rod of length L having a uniform cross-sectional area A, okay, the area is given A, subjected to a tensile force P, as shown in figure below. If the Young's modulus of material is varying from E1 to E2, so these are the elastic constant, Young's modulus, along the length of the rod. Okay, so this is varying from E1 to E2. You have to calculate the normal stress developed at the section. You already know what is the definition of stress. Stress is nothing but the resisting force per unit area. Okay, that means what is the force which is acting? The force is nothing but P only. And what is the area? A. So just to confuse you, they have framed the four options. Okay, the Young's modulus is varying from E1 to E2. So they have given these kind of options. But you know that the stress is nothing but resisting force per unit area only. It doesn't depend upon the elastic constant. Okay, so that means the correct answer for this question is A. This is very simple, straightforward question. But they frame the option in such a manner the student will do the mistake. But you know the stress is nothing but the resisting force per unit area. Because whatever the force which is acting here, that internal resisting force, that will be equal to applied load only. So the stress value will be equal to P by A. And here, if the P force is acting and area is A, so you will get the answer as A. Okay. Now the next thing is how to calculate the internal forces. Okay, so please make a note of this. This is very important question. If you understood this, then I will discuss the gate problem. So in this question, what you have to do, the bar is there whose cross-sectional area is given. That means 400 millimeter square. And that is subjected to different kind of load. For example, 40 kilonewton, 20 kilonewton, 10 kilonewton, 30 kilonewton at the different cross-section. Okay. So you have to calculate, first of all, load on each cross-section and the maximum stress. So for calculating maximum stress is very simple because area is constant in all the three cases. If you find the force value in the 1, 2, and the 3, your problem is solved. Okay, so if you're able to calculate what is the internal forces on the 1, 2, and 3, if you divide with area, you will get the stress. So the main part is of this question is how to calculate the force. Okay, I will discuss the two methods for solving this problem. So in which you are comfortable, you just use that particular method. The first method is called as a method of section. The first method is nothing but the method of section. It is also called as a free body diagram. So what you will do, first of all, you will draw the free body diagram of each and every part. So let us suppose I am taking first, second, and third part. So this is the first part, and this will be the second, and this is it. Now, the force which is acting at this particular end, which is 40 kilonewton. Okay, so this is basically trying to compress this member. If I will talk about the first cross section, that this force is trying to compress this member. So how you will calculate the force on intermediate member? What you will do? First of all, you take the cross section. Let us suppose the cross section is 1. And what force which is acting? 40 kilonewton, which is trying to compress this member. Okay. So that means whenever you are calculating the force on the intermediate member, you have to take the algebraic sum of the force either on the left hand side or the right hand side. Left hand side and right hand side of the cross section. For example, if I want to calculate the force in first member, I will take a section, take the algebraic sum. Only one force is acting, 40 only. So from here also, if you will do, you will get the 40 only. Okay. So if the force is acting at the end point, then it is very easy to draw the free body diagram because one force is acting. So whatever the force which is acting here, same force will act because it should be in static equilibrium. So if I will draw, this force is nothing but 40 kilonewton. So can I say from here also it is 40 kilonewton? Yes or no? So if you want to verify, just take the cross section. This is 40 kilonewton. Take the right hand side algebraic sum. This is 30. This is 20, 50 in this direction. And 1 is 10 is this direction means minus 10. Again, you will get the 40 value. That means whenever you are drawing the free body diagram of end cross section, whatever the load which is acting at end, just write down that one. That means 40, 40. So that means it is very easy to draw the free body diagram of end portion because only one load is active. For example, if I will talk about this one, what is the force? 30 kilonewton. Okay. So no need to calculate from this side. Definitely it should be 30 kilonewton. Hmm. The main part is intermediate member. Okay. So if they want to check your concept, then definitely they will ask for the intermediate member. What you will do intermediate member? Same methodology. Just consider one cross section. Yes. What is the algebraic sum? This is 40. This is 20. So 40 is this direction, which is compressive. 20 is this direction, which is tensile. So if you are considering this is a positive, this direction will be negative. So 40 minus 20 will be 20 only. 20 only. So if this is 20, definitely it should be 20 to maintain in equilibrium. Okay. So this is first, this is second, this is third. That means the force on the first member, if I want to write down, the P1 value is nothing but minus 40 kilonewton I can write, or 40 kilonewton compressive. Why I have written minus? Because you know that whenever any member is there, when the force is acting in this manner, that is the tensile nature, it will try to increase the length. Compressive means it will compress this member. So if the force is acting in this manner, then it will try to compress. Okay. Now, for second member, P2 is equal to minus 20 kilonewton, or I can write 20 kilonewton compressive. For example, if this load is acting in this manner, 30 kilonewton, then 30 kilonewton tensile. Okay, but here also it is compressive. Then P3 value is nothing but minus 30 kilonewton or 30 kilonewton compressive. Okay, so you have calculated the force value. Okay, once you know the force value, can you calculate? Can you calculate the stress value? So stress value is nothing but this is about the force. Stress value is simple. How you will calculate stress? Force per unit area. What is force? 40. What is the area? Let me check. Yeah, 400 meter, 400 millimeter square. So this is kilonewton. I can convert into 10 to the Newton. So this will become 400. Sorry, 4 will cancel it. 100 megapascal. Because this is in Newton, this is in millimeter square. You know that Newton millimeter square is megapascal. So if you solve 40,000 divided by 400 is nothing but 100 only. Similarly, you can calculate for sigma 2, 20 divided by 400, or I will write in Newton, 20 into 10 to the power of 3 divided by 400, then you will get as a 50 megapascal. Similarly, sigma 3, 50,000 divided by 400. So this will be 75 megapascal. Okay. So either they are asking for maximum stress, minimum stress, you can easily find because you know the maximum value is this one. What is the minimum value? 50. So they can frame the question in this manner also. Which member or which section is having a lower value of stress? So which section having lower value of stress? That means 50 megapascal. Out of these three, this is the minimum. So for that, you have to calculate the force. And how you calculate the force, I have discussed already by using the method of section. Okay, this is the first method. Second method is axial load diagram. Okay, so in which method you are comfortable, either the method of section, just follow that one. But personally, I believe that the second method is easy. Why? Because the second method basically helping for the magnitude as well as the direction. So what I will do, I will draw a zero line, and above that zero line, I will consider as a tensile. That means if any tensile load is acting, that is above, I will draw. For compressive, I will draw the below. Below means below that particular line. Let us suppose this is the line. This is the line. And I will mark some point. So let me take this figure first so that it will be easy to understand. Just one second. Now see, first of all, I will mark the point. Let us suppose this is A point, this is B point, this is C point, this is D point. Okay, this is A, this is B, this will be C, and this is D. Okay. Now, if any compressive force is there, what I have told you, you have to draw the vertical line below that particular zero line. This is the zero line, 40 kilonewton. This is compressive. Okay. Then I will draw a line 40 kilonewton, which is downward. Now, the 40 kilonewton only load which is acting on this member, there is no load intermediate. So what I will assume, there is a constant because throughout this member only 40 kilonewton is acting. Now there is a 20 kilonewton which is acting in this manner. That means this is a tensile only because this is nothing but compressive. So this will be tensile in this direction. So what I will do, 20 kilonewton, I will move upward, because tensile means you have to move above. That means upward. Compressive means below. So this is nothing but 20. So 40 minus 20, can I write? This is 20 kilonewton. Below means there is a negative. Now again, I will draw a constant line. I will draw a constant line. Now, if you see here, then again 10 kilonewton, which is acting in the compressive manner. That means in this direction. So what I will assume, then it will go down. So there is a 20, then again 10 means 30, then again constant, then again constant. Then if you see, there is also a 30. So there is also a 30 means it is acting in this direction. So I will move above 30. So this is 30 kilonewton. This is 20 kilonewton. This is also 30 kilonewton. So the main thing is, whenever you will draw the axial load diagram, it should be closed. Now you can see here, it is closed only. So now all are below the zero line. That means all are negative. So you can easily tell the portion AB, portion BC, or second, third portion are subjected to which kind of load. So if I want to write similarly, P1 value is, what is the P1 value? P1 value is, this is 40. 40 means, I can write here, 40 kilonewton compressive. Okay. 40 kilonewton compressive means, we'll simply write. What is P2 value? P2 value is, what is the load on P2? This value, which is nothing but 20 kilonewton, and it is a negative 20 kilonewton compressive. What is P3? P3 is nothing but 30 kilonewton compressive, and same result you got from the free body diagram also. Okay. So either you can use the method of section free body diagram, or you can use the second method, which is nothing but the axial load diagram method. Axial load diagram method. That means you are drawing the axial load diagram. Whatever the axial load which is acting, you are drawing the diagram, and from the diagram you are identifying that which member is subjected to what kind of force. So the intermediate force member you can easily find. What is the question? The force on BC. The force on BC, load acting on each section, you have calculated. The maximum stress means, okay, the area is constant. If area is constant, you know that the stress is force per unit area. If area is constant, wherever the force is maximum, the stress will be maximum. So this is basically a force which is maximum 40 kilonewton. So 40 kilonewton divided by area is 400. That means 40,000 divided by 400, you will get as a 100 megapascal. So same result you got from this one also. Okay. So either you can follow the method of section, or you can follow the axial load diagram. But the thing is, whenever the question is coming, that you have to draw correctly. That means your answer should be correct. I hope this question you understood. Yes or no? Both of you, Jagan as well as Raj. Is it clear?
Clear, sir.
Yes, sir.
Understood, sir.
Okay. So
Sir, regarding this type of question, I have doubt, sir.
tell me.
Um, Sir, in this question, sir, of this bar, sir, at the first bar, sir, to its left, a force of 40 kilonewtons is acting, sir, and then, sir, um,
Okay.
then, sir, to its right, sir, another force of 20 kilonewton is acting towards left, or not towards that first block, sir, here. So, so for that, for this AB only, sir, how I have to draw free body diagram, sir? On the left side, I have to draw 40 kilonewton in the free body diagram, but at the right side, what I have to draw, sir? Regarding this one, I
Okay.
have a lot of confusion, sir.
Okay.
Okay,
Okay.
here
Okay.
first.
Again, I will explain. So this is your first of all what we call as a section. What you will draw whenever any bar is given. Okay. So this is the section you are drawing. Now,
Hmm.
what you will do, what I have told you in method of section, you have to take algebraic sum. Algebraic sum. Let us suppose this member, I want to calculate what is the force on this member. So I will
Hmm.
take a section. Either you take the algebraic sum of this one, or you will take the algebraic sum of this complete. So this is only 40 kilonewton. So a 40 kilonewton from the left side, that means 40 kilonewton here. Suppose if you want to verify from this side also, just take the algebraic sum. This value is 30. This is value is 20. So 30 plus 20 is 50. Now this force is acting in this direction. That means it will become minus. So this is 50 minus 10 is 40 kilonewton. So same force, 40 kilonewton. How the direction is decided? Because 30 and 20 is in this direction. So the direction will be this one only. So this 40 kilonewton, which is also acting in this one. You can also understood because if 40 kilonewton is in compressive, so then 40 kilonewton should be from here. Otherwise, this block or this what we call as a bar is not in equilibrium. It should be in equilibrium. So whatever the force which is acting here, the same force will act here. But I have given you one trick. Whenever the force on the extreme end, what you will do, whatever the external force is acting, just draw the same value here because you know that the bar should be in equilibrium. So once you will take the left hand side section, only one load is acting. So why you are calculating from the right hand side? So that means for extreme end, just take whatever the load is acting, that will be the answer. So 40 kilonewton. So from there also 40 kilonewton. But if you want, you can calculate from right hand side. Similarly, you will do for the second section also. Take the section. What is the load acting? 40. Okay. 40 kilonewton in this direction. And this is 20 kilonewton. So 40 minus 20 is 20 kilonewton. How you will decide the direction? This force is acting in this value because this is magnitude is more. So the direction will be this. Same thing I have superimposed. Now is it clear?
Clear, sir.
Okay. So this is the question they are asking, how to calculate the intermediate force, or they can frame the question based on the stress. So I will ask you one question. I think 2018 or 2017 they have asked. Same type of problem. What you have to do? You have to calculate the value of stress in segment QR. That means at this intermediate member you have to calculate. Just do with both the method for verifying, or if you are comfortable with method of section, follow that one. But I just want the correct answer. What you will do? Just take this section and calculate the force on each member. Why they have asked about the intermediate member? Because you know that in case of extreme end, it is very easy to draw the free body diagram. That means whatever the force is acting here, if you will draw, the same force will act in this direction. So 63 kilonewton. The only the intermediate member you have to take the algebraics. Okay, so please try to attempt. Otherwise, I will explain. And once you got the answer, so please mention in the chat box.
Forty MPa.
Let me check, Jagan. What is the answer? So Jagan has given 40 megapascal. Fine. So one more minute, I'm just waiting. Then after that, I will start the discussion. Okay. Okay. Once you have done with the method of section, can you verify with the what we call as the axial load diagram, Jagan? Or if you have drawn through the axial load diagram, just calculate by using the method of section. So are you getting the same results or not? Now you see, if you have drawn or if you have solved this problem, the first thing is for the left hand and the right hand side member, you can easily draw. There is no problem because whatever the external load is acting, I have told you, just apply that particular load because let us suppose this is 63 kilonewton from this side. If you take the algebraic sum from here also, algebraic sum means whatever the force acting on this side, only 63 is acting. If you consider from this side also, you will get the same. How? 35 plus 49 minus of 21. So what is 35 plus 49? This will be 84. 84 minus 21 is 63. Okay, so same value you are getting. So why you will consider the right hand side? Because all three forces are there. If four forces are there, that means you have to calculate. So for extreme end, whatever the force is acting, just draw these. For making a what we call a free body diagram of these two is very easy. Whatever the force is acting, just apply that. Okay. Now the thing is how you will calculate the intermediate force. The same approach. Consider a section. Take the algebraic sum either right hand side or left hand side. Okay. So now I am going to discuss. So you can just verify did you got the correct or not. But before that, let me take this figure in the next slide. Now see, let us suppose this is the first member, this is the second, and this will be the third one. For first member, it is very easy. First member means this is 63, then I will write 63 also here. Not an issue. Third member also very easy. This is 21. So from here also 21 to maintain equilibrium. Now comes to the second part. Take the section. Take the algebraic sum. What is the algebraic sum? 63 in this direction, which is positive 63. Okay. Or you can consider this direction is positive, then tensile. Then this is a compressive minus of what is this value? 35. So 63 minus 35 is 28 only. And 28 which direction? This direction because this magnitude is more. So this value will be 28 kilonewton. Okay. Now someone will tell, sir, I want to calculate from this side. Okay, you can verify. This is nothing but 21 or okay. So this is, you are taking the cross section here. So 49 positive minus 21. What is this value? 9 minus 1 is 8 and then 28. So from here also you will get the same. So this is also 28 kilonewton. Okay, so you have calculated the force in the intermediate member 2, which is nothing but 28. But what you have to calculate? You have to calculate the stress value. What is the value of stress? The stress is nothing but the force per unit area. That means 28 into 10 to the power of 3 divided by area is nothing but 700. So what is this value? 40 megapascal. Very good, Jagan. Your answer is correct. 40 megapascal. Now you see, this question was asked in 2 marks. So if you know the concept, okay, so hardly it will take you, hardly it will take for solving this problem less than 2 minutes. That means 1 minute you can save, and that time you can utilize for other problems. But if you know the concept, there is the only problem for considering this or solving this problem is how you are deciding the direction. I have told you take the algebraic sum. Whatever the force is acting, 63 plus 63. What is this value? Minus 35, 28. So what is the direction 28? This is maximum, so 28. Now this is the first method which is called as a method of section. Now the second method is axial load diagram. Axial load diagram. How you will solve with the axial load diagram? Very simple. So I will take this figure in the next slide. Okay, now see, 63 will be tensile which is above. 63 will be tensile which will be above. Now this is a zero line. Let me mark some points. P, I think this is Q, Q, and this will be the R, and this is S. 63 kilonewton. Then there is a constant. Then what is the force? 35, which is in this direction. So 35 will be in the downward. So if this is 63, this is 35. Can I say this is 28 kilonewton? Then again constant. Then from here, 49 kilometer again in this direction. Okay, so this is 28 kilonewton. So 28 kilonewton and then 49. So this is 28 is positive. So 28, 49 minus 28 is 21 only. So it will go 21 downward. So 21 downward, then again constant. So now you can see here, this force is acting here. So that means tensile. So this is positive. So this is negative, this is positive, this is positive. So from the axial load diagram, you can easily tell the QR, which is subjected to a 28 kilonewton. Same result you got from method of section also. It means either you can use method of section, either you can use axial load diagram, you will get the same result. Okay, but you have to practice at least one or two questions. What two questions I have discussed? Once you know how to draw this one, then it is very easy. So one more problem I will discuss, but additional with this, what we call as a free body diagram and this axial load diagram, I will introduce one more concept, that is the elongation. Okay, but for elongation also you have to know how to draw the free body diagram. So for this particular question, if I want to write down what is the load on this first, second, third, is nothing but 63 kilonewton tensile. P2, because it is very easy. This is positive, this is also positive. So can I write 28 kilonewton tensile? And P3 is nothing but 28 kilonewton compressive. Or you can see from here also it is trying to compress, then definitely it will be compressed. So that means either you can use axial load diagram or method of section. But I just want to know from your side, in which method you are feeling like it is easy, both of you. Or if you understood both the method, then it will be fine. Which method you are feeling easy? Method of section or axial load diagram?
Sir, can you show me both method once?
This is the axial load diagram method, and that will be the method of section. Method of section means you have to take the section and consider the algebraic sum of load on the left and right hand side. Okay, both are fine. Jagan is telling both are fine. Okay,
Sir,
so if you
for
are
me, this
comfortable,
method of section is easy.
okay, fine. So the thing is, the main thing is no one is asking which method you have used. If the question is coming, just try to get the answer correct. That is my main. Okay. So this method of section or axial load diagram in which you are comfortable, you can use any method. Now the next thing is, before coming to this particular problem, I just want to introduce some concepts you already know, but I'm just giving a quick recap. You know that whenever a bar is subjected to a load, when a bar is subjected to a load, it will undergo the deformation. Yes or no? So in deformation means what is the deformation of that? PL by A. How it is came? Because you know that the stress is directly proportional to strain. So stress is equal to E into strain. What is E value here? E is the Young's modulus. This is the strain. So strain is change in length by original length. Change in length by original length. And stress, you know that P by A. So from here, if you want, the elongation is nothing but PL by A. Very simple. So based on that, I will discuss one problem in which you have to calculate, or some condition is given, use the concept of elongation. Okay, the same problem. In this same problem also, if the dimension is given, you can calculate the change in length also. But how? I will discuss. Now, this question was asked in the GATE 2016. What is the question? A horizontal bar with a constant section is subjected to loading as shown in figure. The Young's modulus of AB, that means the modulus of elasticity, is given as 3E. And for this BC, the modulus of elasticity is E. Now you have to calculate the ratio of P by F, but one condition is given for the deflection at C to be 0. That means at this point, when the deflection at C to be 0, what will be the ratio of P by F? That means, suppose if you want to calculate the deflection, that means delta L is nothing but the deflection of this plus deflection of this, because the both bar are connected in series. So the deflection is deflection of first member plus deflection of second member is equal to 0. Okay. Now, deflection of one, you already know what is the deflection formula or deformation formula, PL by A. Here also you can write PL by AE. But the load which is acting on this member and this member will be different. That means there is a use of method of section and axial load diagram. So this is a mixed type of problem. First of all, you have to calculate what is the force which is acting on this member. Once you know, then use this relation PL by AE, your problem is solved. Okay, so this problem I'm going to discuss. The next problem you will try to solve. So what you will do, first of all, let me take this diagram. So change in length, you already know PL by AE, PL by AE. So it is given that the deflection at C point is 0. It is already mentioned the deflection at C point is 0. Okay, a bar is there which is subjected to different kind of load. Modulus of elasticity is given. Now it is given that if the deflection at C point is 0, what is the ratio of this P load and F load? Okay. Now deflection at C at 0 means the deflection at C at 0 means the deflection of BC. Can I write deflection of BC member plus deflection of, or the usually the word should be used as a deformation. So the deformation of AB is equal to 0. Okay, fine. What is the deformation or elongation formula? PL by A. Okay. That means the load which is acting on this section and this section is different. But the length is same. Yes. Area is same. Yes. The area is horizontal bar with a constant cross-sectional area. That means the area is constant. Modulus of elasticity, it is varying. So in one case, it will be E. In another case, it will be 3E. Okay, so what I will do, let us suppose if I will take this particular cross-section, BC, what is the force acting? I have told you, take the algebraic sum, only F is acting. So similarly from here also F. First section. I'm just making as a, okay. Otherwise I will make as a second, not an issue. This is the first one. Now, let us suppose this is the bar AB. This is the bar AB. What is the force which is acting? Take this particular section and take the algebraic sum. What is the algebraic sum? This is basically F is nothing but tensile and P is a compressive because it is trying to compress this section. So F minus P can I write? So the load value will be F, and in this direction, P is in this direction. That means F minus P. The algebraic sum of force is F minus P. So F minus P is subjected for AB member. What is the Young's modulus? Here it is E, here it is 3. That means you can easily solve the deformation of BC member. Deformation of BC, how you will calculate? You know the force. What is the force here? F. Okay, I will write down F. What is the length? Length is L. What is the area? Area is constant, but Young's modulus is E. Okay, for BC member I am talking about. Now for AB member, what is the force? Force is nothing but F minus P. What is the length? Length is L. Area is A, but Young's modulus it is given as 3E. So I will write 3E, which is equal to 0. So now you can easily solve this. A into E will become 0 if you multiply here. So L will also cancel out. So F by, okay, so what I will do otherwise, I will take L by AE is common. L by AE is common. So F plus F minus P divided by 3 is equal to 0. So can I write F plus F minus P by 3 is equal to 0? So what is this value? 3F plus F minus P divided by 3 is equal to 0. That means 4F is equal to P. Then what you have to write down? P by F, which is equal to 4. So what is the correct answer? The correct answer for this question is 2, and this question was asked in 2 marks. If you understood how to calculate the force, remaining is nothing but this formula. But one more mistake the student will do. So from here, it was asking what is the ratio of P by F. But what the student will do, once they will calculate in hurry, they will write F by P is equal to 1 by 4, which is 0.25, and they will keep the 0.25, you will get the 0 mark. So before answering the final value, that means before answering the question, just read the question carefully, what it was asking. It is the ratio of P by F or F by P. Is this question is clear to both of you?
Yeah, okay, sir. Here, for the bar AB, I will get F minus P only. Means at the fixed side, means at the A, sir, I will get F minus P only because in this bar, sir, at the B, sir, a force of P is acting towards it, sir, and the F is acting rightwards from point C, sir. So if means F minus P will be there, sir, under just like in the previous case also.
Correct. What about Jagan? Did you understood? Jagan, is it clear? This question is clear, so that I can move to the next one.
I understood.
Okay. Then,
Understood, sir.
if you understood, please, yeah, you are telling something.
Nothing, sir. Understood the question, sir.
Now, please try to solve this problem. Okay, now let me first explain. The previous question, they have given the E. Now, what they have done, they have given the value of E as well as the area. That means they made that same question in the numerical format. Okay, instead of L and A, they have given the data, but the concept will be same. If you understood the concept, your problem is solved. What you have to calculate the total change in length of a rod due to this particular rod. What you will write? The total change in length means change in length of this bar, change in length of this bar, change in length of this bar. That means you have to calculate first of all what is the load which is acting on these three members, and this I have discussed. Then after that you have to use total change in length means change in length of this. Let us suppose KL plus change in LM and change in MN, and you know the formula PL by AE. Once you know the P force, length is given, area is given, E is given. Now you can and tell me what is the answer you are getting. Okay, so try to solve this problem, or once you got the result, so you can mention in the chat box, or you can just unmute yourself and tell me the final answer. So I'm giving you for solving this problem 2 minutes. Then after that I will discuss.
Sir, in this question, sir, regarding this, I also have doubt, sir.
Tell me.
Sir, here in this section LM, sir, we have two loads, 250 Newton acting inwards and 200 acting to the left in the bar, sir. Sir, here, sir, for this LM, sir, both sides, sir, if for knowing loads on both sides, sir, I have to add this 250 and this 50, sir, and I have to subtract 200, sir. Then I will get equal loads for this LM, sir.
I told you whenever you want to calculate the force in member, just take the cross section. This is the cross section I am taking. Either you take the algebraic sum of this one, or either you take the algebraic sum of this one. Take the cross section at the center, whatever the force which is acting on left hand side or right hand side.
Yeah, got it, sir. You have explained earlier, but when it comes to a different question, I get confused even if I know this method.
What is the confusion in this one? Take the section. What is this 100 and this is 250? 100 minus 250 is nothing but because this is tensile. Minus 150. Minus 150 means 150 compressive. Again from you will take from this side. This is 200 which is in this direction compressive plus of 50. From here also you are getting 150. What is the confusion? Take the algebraic sum, that's it. You want to explain from me only, I will explain, not an issue. But at least you try to attempt. I have given you 2 minutes. Just do some exercise, do some experiment. so that you will get to know like where you are doing the mistake. Because at the end, I will discuss this problem, not an issue. Okay. So you have 1 minute 30 seconds. Do it fast. If you got the result, just let me know.
Ten micrometer.
In micrometer. Okay. So, Jagan, let me check what is the answer. But whenever you are giving the answer, just tell complete minus 10 micrometer. Okay. Because this also having a significance. I understood because there is only one option, that is the B option. But minus 10 is also having meaning. Minus 10 means it is totally the rod will be in under the compression. Okay. Because why I am telling this? Because sometimes they will make the NAT question. Because if you make a habit of
Understood.
calculating the magnitude, you will keep as a 10, you will get the 0 marks, even if you have invested 3 minutes for solving this problem.
Yeah, by
So,
solving, I got -10 only. So sorry.
yeah, yeah, not an issue. I'm just correcting your mistake so that you won't do these kind of mistake in your exam. Okay, so let me check, Jagan. What about Raj? Calculate the force.
For this question, sir, I'm unable to calculate even if I know the method also.
Okay, not an issue. I will explain. Now see, if you have a doubt, I'm here. I'm explain. I will explain you. Not an issue. So let me take this one. But at least I'm expecting you can easily calculate the force in the member. Okay, because I have discussed already what we call two question, how you will calculate the force in this one, this one, this. But total change in length, if you are not able to find out, then I will tell you. Even I have given you the hint. Total change in length is nothing but PL by AE for all the three cross sections. Okay, so let me take this particular figure. Now see, first of all, this is the one cross section. This is the second cross section. This is the third. What I will do, I will draw the free body diagram. Okay, this is the first, second, third. So this one will first, second, and third. What is the force acting here, Raj? It is 100. So from here also 100. I think this thing is fine for you. Now from here, okay. So whenever the question is coming like this, just to draw the free body diagram of end section, because it is very easy. Only one load is acting. You can easily draw 50 Newton. Here it is also 50 Newton. Now the question is, what is the force on this intermediate member? Can you please tell me, Raj? What is the force on this intermediate member? Take the algebraic sum left hand side or right hand side.
Okay, sir, I will take from left hand side. 250 minus 100, 150, sir.
150, which is a compressive or tensile? That is also important.
Sir, I can't see here compressive or tensile, sir.
So if
Because
you
the
taking this,
250,
so okay, so 250 is the higher in magnitude. Whatever the sign of this 250, the same will come, no? That you agree?
okay, understood, sir. We,
And
I need to
what
consider
is,
highest magnitude.
yeah, see, for example, if you have 50 rupees and you are giving 20 rupees to other person, how much you will left? 30 only, no? Because 50 rupees in that means you have means that will be positive only. You are subtracting something. So whatever the sign is coming from this one, the same sign will come. No, same thing you can apply here. 250 is the higher magnitude. Whatever the direction of this, same direction will come. So what is the net magnitude? Net magnitude is nothing but compressive. 250 minus 100, which is nothing but 150. 150, if you able to calculate 150 from this one, directly you write down 150 because that should be in equilibrium. If you want, I can calculate from this one also. This is 200, which is minus 50. Sorry, this is minus 200, which is compressive, plus 50 minus of 150, or you can write down this one. And whatever the direction of this, same direction you are getting here. Compressing, how I am deciding? This is the section. What this force is doing? This force is doing compressing. That's why this is nothing but compress. Now is it clear?
Okay, sir. Here the okay, sir. Here compression force is taking, sir, because if I see as per this magnitude here on the left side, sir, the rightward one has higher magnitude of 250 newtons, sir, and left is of 100 newtons acting to left, sir. Anyway, if I do force summing, I will get 150 only, sir. But this
150
150 is
only
the compressive force.
compressive because it is coming from 250. Okay. Okay.
Okay, sir.
So once you understood the force, then there is no problem. What you will do? Change in deformation. Total change in deformation is deformation of KL, deformation of LM, deformation of MN. What is this value? That means, can I write PL by AE for KL section? Similarly for PL by AE for LM section, and PL by AE for what we call this value. This is nothing but MN. Okay, this you have to calculate. Okay. Now what I will do, area and the Young's modulus is constant. Okay, area and Young's modulus is constant. So I will take outside. So 1 by area. Area is nothing but 25 and E is 200. Again, one more thing. This is given in gigapascal. Okay. So you know that 1 megapascal is Newton per millimeter square. What is 1 gigapascal? 1 gigapascal is 10 to the power of 3 megapascal. Or you can write down 10 to the power of 3 Newton per millimeter square. So if you are taking in Newton per millimeter square or megapascal, so try to convert this gigapascal also in megapascal. Okay, so don't do the mistake this one. Otherwise, you will end with the wrong answer.
I
Even they
didn't get
have
your
given,
point, sir.
this is the unit conversion, no? Very simple. 1 megapascal, you know that Newton per millimeter square.
Yes,
Gigapascal
sir.
is 10 to the power of 3. Gigapascal means 10 to the power of 9 Pascal, or 10 to the power of 9 means 10 to the power of 3 into 10 to the power of 6 Pascal. What is this 10 to the power of 6? Megapascal only. No? Same thing I have written here. It means 1 gigapascal you can write 1000 megapascal. Okay, so what I'm trying to say, if gigapascal unit is given, try to convert in megapascal, because all the dimensions are given in Newton as well as millimeter square. Here you can see it should be one unit. No, for example, if distance is given in meter, so you cannot consider the speed in millimeter per second. You have to convert in same unit. No, that's what I was telling. So 25 200 into 10 to the power of 3, because this is given in gigapascal. That means 10 to the power of 3 megapascal. Now A and E you calculated. What is the length? Length of this bar. Let me check. This is the P value. P value is 100. Okay. How I am getting this? P is tensile positive. That's why I'm taking as a positive P value. What is the length? 500. Now the thing is, why I have told you consider the sign also, because if you see this is compressive. For compressive means you have to consider minus load 150. What is the length of this bar? If this is 500, this is 400. Can you please tell me what is this length? Total is 1700. What is this length?
Minus 150. Sir, here, okay, 150 into that for that length, sir. From this 1700, I have to subtract this 500 and 400, sir. Means 1700 minus 900, 800, sir.
800. That means this length is 800 plus what is the force? 50 Newton into
50.
400.
Mm.
Okay. So you got the P into L value. A and E are constant. That's why I've taken outside. Now the main thing, the student will do the mistake while considering this sign. If you wrongly interpret this result, that means 150 if you make a tensile, if you consider positive, you will get the wrong answer. Okay, so just focus on this one, how you are getting the direction based on this 250. So that is compressive load. That's why I have taken as a minus. So minus 15, sorry, minus 150. So let me take this in the next slide. Now see, can I write this is nothing but 5 into 10 to the power of 6? 25 into 2 is 50, and this is 20, that 10 to the power of 5, and from 50 one more come, 10 to the power of 6. If you solve, you will get 5 into 10 to the power of 6. What is this value? 5 into 10 to the power of 4. What is this value? 12 into, it is 8 or 800, sorry, this will be 800 only, minus 150 into 800. So this will mean this 12 into 10 to the power of 4. 5 into 4 is 20. That means 2 into 10 to the power of 4. So can I solve this one? 5 plus 2 is 7, and this is 12. That means minus 5 into 10 to the power of 4, and this is 5 into 10 to the power of 6. This will cancel out. Then you will get as 10 to the power of minus 2 meter. Sorry, 10 to the power of minus 2 millimeter. So can I write this is 1 into 10 to the power of minus 5 millimeter? Sorry, meter. Because you know that 1 millimeter is nothing but 10 to the power of minus 3. So if I want to convert into the micrometer, what is the answer? 10 into minus 10 into micrometer. Because you know that 1 micrometer is 10 to the power of minus 6 meter. Okay, so this is 10 to the power of minus 5 meter. So if you multiply with 10 and divide with 10, then it will become 10 to the power of minus 6, and then you will get the minus 10 micrometer. And your answer is correct, Jagan. The correct answer for this question is twice.
Okay, sir. 10 micrometers means, sir, 1 to 10 power minus 5 meters only.
1 micrometer is 10 to the power of minus 6 meters. So actually, I am expecting this unit conversion and everything, you know. This is basic. This is not a, this is from 12th standard you are telling. Understanding what is micrometer, what is millimeter, what is nanometer.
Okay, sir. 1 micrometer means 10 power minus 6 meters.
Have you
Okay.
studied in 12th class? The resistance you are giving as a 5 micro ohm. What is this micro meaning? 10 to the power of minus 6 only, no?
Okay,
Did you
sir.
understand?
Yes, sir.
Okay, so I think you understood this problem. Now comes to the next problem. That is question based on the plane stress. Okay. So first of all, let's try to understood what do you mean by plane stress. Then I will move to that particular problem. The plane stress means the stress developed in one of the direction will be zero. Okay, the plane stress means the stress developed in one of the direction, it will be zero. Then you can solve this particular problem. So that plane stress problem is also known as a biaxial stress problem, biaxial state of stress. So the plane stress problem is, plane stress problem means, plane stress problem are those problems in which the stress developed in any one of mutual perpendicular direction, passing through that point, passing through that point are assumed to be zero, are assumed to be zero. That means plane stress problem means when the stress is acting only on one plane. One plane means x and y direction. In z direction, the stress value will be zero. Okay. So that is the meaning of plane stress problem. So there are some important condition for that. How you will assume that is a plane stress problem or not. So if you remember these two conditions, you can easily identify. Okay, then you will easily solve that particular problem. So what is the first condition? The one of the dimension in that direction, one of the dimension in that direction are very, very small, very, very small as compared to, as compared to other two direction. Other two direction. Other two direction means, let us suppose this is x, this is y, this is z. So one of the dimension in that direction. So let us suppose I am telling the stress value will be in one of the dimension is 0, which is already I have mentioned, in which the stress developed in one of the direction. One of the direction means either in z direction, either in y, or either in x. So only sigma x, sigma y is there, sigma z value will be 0. Then how you can identify when one of the dimension in this direction, z direction is 0, almost very, very small. That means the z direction stress value will be very small, means you can consider a thin plate. You can see this is the dimension in y direction, this is the x direction, but the thickness value is very small. That's why the plane what we called as a thin sheet is considered as a plane stress problem. Why? Because one of the dimension is very small. Second condition is load acting in small dimension direction should be small. That means the load is also acting in that small dimension direction should be small. Okay, so the best example of plane stress problem is thin plate. Okay, so let's try to understood with one example. So for example, this is basically one thin plate. Now if you see here, one dimension is length, one dimension is width, another is thickness. So the thickness dimension direction is very small as compared to other two, so it is satisfying first condition. Second condition is load acting in that direction will be very small. Okay, so let us suppose this is the y axis, this will be the x axis, this will be the z axis. Okay, this is the x, this is y, and this is z. So let us suppose if I am taking the dimension, this is 500 mm, or this one I can take as a 300 mm, this dimension 300 mm, this is 500. The thickness I am assuming as a 5 mm, which is very small as compared to other. Okay, now the load which is acting, let us suppose in the y direction, 10 kilonewton in the y direction. And what about x? X is 200 kilonewton, and the z direction will be, the load value will be is nothing but 80 kilonewton. Okay, now the meaning of plane stress problem means the stress developed in one of the dimension will be very small. Stress developed in one of the dimension is very small, means either the stress value in the z direction is small, or y direction is small, and x is small as compared to other two. So I will check what is the value of stress in x direction. Stress in x direction means the load acting in x divided by area. Stress in y is load in y divided by area, and the stress in z is nothing but load in z divided by area. What is the load in x? Load in x is 200 into 10 to the power of 3, because it is in kilonewton. What is the area of this? This is the load which is acting on this particular cross section. What is the area of this cross section? 300 into this thickness. 300 into this thickness, which is 5. If you solve, then you will get this value cancel out. Then 2 divided by 15. So that means approximately this is 1133.33 megapascal. Similarly, for Py, what is the load acting in Py? 10 kilonewton. 10 kilonewton means 10 to the power of 3. What is the area? Area is nothing but this one. This is the area. This area you have to consider because the load is acting the upward direction. What is the area? Area is nothing but this 500 mm, and this area is 300. So can I write 500 into 300? So this is nothing but this 40 will cancel out. So 1 by 15 is approximately 0.06 megapascal. Okay. Now sigma z is nothing but, sigma z means the load in z. Load in z means, what is the load in z? 80 kilonewton. 80 into 10 to the power of 3 divided by area. What is the area? 5 into this area, which is nothing but 500 mm. 5 into 500 mm. So 8 into 10 to the power of 4 divided by 25 into 10 to the power of 2. So if you solve, then you will get 32 megapascal. Now see, this value, this value you are getting as a 133 megapascal. This is 32, and this value of stress is very small, or we can say that negligible as compared to other stresses. What is the condition? The load acting on the one of the dimension, which is z direction, y direction, this is thickness direction, is very small, that is 10 kilonewton. And the dimension is also small, which is satisfying both the condition. One of the dimension in that direction are very small as compared to other two. Yes, this dimension is very small. And the load acting in small dimension direction is also small. So if the load is small, but the area is maximum, automatically the stress value will be coming out to be less. So the plane stress problem means when the stress developed in one direction is very small or assumed to be zero as compared to other two. That is the meaning of plane stress problem. And based on this concept, they have asked this particular question. Okay, but before that, you first write down this important concept, these two condition and the meaning of plane stress. Then I will discuss that problem. So now can you try this particular problem based on that summary which I have discussed in the plane stress? Okay, so read the question carefully and read the option and try to find out which one will be the correct. Definitely you will get the answer. I'm giving you 2 minutes. Okay, read the question carefully and try to visualize. They have clearly mentioned a thin plate is there. Thin plate means you already know. Thin plate is the example of plane stress.
Option A, sir.
So I'm just waiting from other student also.
Sir, I think option pressure, okay. Sir, I think here two options are correct. No, no, sir, not two options. Normal stress is 0 in the z direction. Option A, sir.
Okay. Janice, can you please tell me which option will be the correct? So the two students have given the answer as a. Definitely this answer is correct. But if you don't know the concept of plane stress, I'm pretty sure you will not able to solve this problem. And this problem was asked 2 marks. Without lifting a pen, you can easily solve if you know the concept. What is the plane stress? They have clearly mentioned under the assumption of plane stress. But if I'm not giving this assumption also, you can easily tell, yeah, it is a thin plate. Thin plate is the example of plane stress. Your problem is solved. Now, this is basically a thin plate like this. Okay, so I'm just drawing a diagram. This is your thin plate. I hope you are able to visualize. This is basically the direction X. This is basically the direction X, and this is the Y direction, and this will be the Z direction. Z direction means this thickness. Now, if you see from here, what you will get? A circle only, which is X direction and Y direction. What about the Z direction? Z direction means thickness. So they have given you the front view as well as the top view. The front view as well as the top view. Okay. So the Z direction is the thickness direction. You know that whenever the one of the dimension is very small, then the stress developed in that direction will be zero. So I have clearly mentioned here. So one of the dimension in that direction is very small. Then we can say that the stress value will be zero. That is the condition of plane stress. Okay. So what is the correct answer for this question? The normal stress is zero in Z direction. Very good. So whatever I have explained, you have visualized this, and this is 2 marks problem. This is not 1 marks problem. Why? Because if you have a thorough understanding of concept, then you will able to solve. Okay, so very good. Raj and Jagan, you got the correct answer. Now, the next problem is this one. What is the problem? Bimetallic cylindrical bar. Okay, so two bar are there of area which is given as 1 meter square is made up of bonding steel. That means this is steel and aluminum, they are bonded together to maintain the tensile axial strain. Okay, so they have given the strain value which is 10 to the power of -6 in steel bar. Okay, and compressive axial strain of 10 to the power of -6. That means in the previous question, if you see, you have to calculate the total strain or the total change in length, but they have given the strain value. Then you have to calculate the how much force you have to apply here along this particular direction so that it will develop the strain in the steel bar is 10 to the power of -6 as well as 10 to the power of -6 in the aluminum bar. Okay, read the question, try to solve. Again, I'm telling you this problem is also similar problem as compared to the whatever I have discussed. Okay, you have to calculate this p value which is acting at the center of the steel and aluminum where these two material or these two metallic bar are bonded. Okay, so I will give you one hint. So this is the P force. This is the P force. Let us suppose the P force which is acting here. Can I say this P force will be balanced by the some force on the steel and some force on the aluminum. Okay, so what you will consider, so let me take first of all this diagram here. Now see, this is the P force. If external force is acting here, that means for resisting that, there will be a reaction here. Let us suppose this reaction I am considering the load on the steel bar. Similarly, if the force is acting here, the total reaction at this point will be P of L. Yes or no? Because this is at the fixed end, so definitely there will be reaction which will support this particular load. If external load is acting here, so resisting force will be opposite. So P of steel, P of aluminum, can I write P? Now, whatever the external load which is acting here, either it is a 200 kilonewton, 400 kilonewton, that will be balanced by these two. That will be balanced by these two. That means I can write P of steel plus P of aluminum is equal to P. This is the first equation. Now the second equation is, you know that the first equation is P is, you have to calculate, P value you have to calculate. The P steel and aluminum is also unknown, but how you will solve? If anyhow, if you got the relation between steel and aluminum in terms of P, your problem is solved. You know that both the bar are fixed. Both the bar are fixed means the total deformation of this complete bar will be zero. Yes or no? Because both end are fixing. For example, if it is trying to elongate this bar, the aluminum will compress. For example, after t is equal to 5 seconds, this bar will be like this. This is steel and this is aluminum. So steel is elongating, aluminum is compressed. So, but the total deformation will be zero because these are the two fixed ends. So I can write the total deformation will be zero. Total deformation zero means deformation of steel plus deformation of aluminum will be zero. This is the second condition. Now, how you will calculate the deformation of steel and aluminum? You already know. So P of steel into length, which is L by 2, upon area. Area is nothing but, let me check. Area is given or not. Okay, not an issue. The area will be cancelled out. So I'm just assuming area is A. What is the Young's model of steel? Young's modulus of steel is 200 gigapascal, and this is, so let me write first, 200 gigapascal, and E of aluminum is given as 70 gigapascal. Yeah, 70 gigapascal. Now, this is nothing but P of aluminum into length L by 2, area into E of aluminum, which is equal to 0. Okay, so this area will become 0 here. So I will cancel this, because if you take the LCM, this area is nothing but the constant, which will become 0. So this is given, L by 2 will also become 0, or you can take L by 2 common, L by 2 into A. So what value you will get? P by steel, E by steel, plus P by aluminum, or E by aluminum is equal to 0. Okay, so this value you know already. That means, can I get the relation between these two? Yes. So can I write like this? P of steel, P of steel P of steel divided by E steel is equal to minus of P aluminum by E aluminum. Or one thing also you can do, just convert this aluminum in terms of steel only. So can I write P aluminum from the first equation, P minus P steel? Okay. So that you will get only one unknown, which is P steel. In terms of P, you can write. So from this one, P steel divided by E steel. E steel is, which is nothing but 210, is equal to P aluminum is P minus P steel. So can I write? It will become minus, so P steel minus P divided by 70. Yes or no? Then what is this value? This is 33. Now let me take in the next slide. Just P aluminum P steel minus P. You will get P steel divided by 3 is equal to P steel minus P. So from here, you will get P steel is nothing but 3P by 4. Similarly, once you know the P steel 3P by 4, if you put here, then you will get P steel is 3P by 4 means you will get P aluminum is P by 4, P by 4. But what you have to calculate, the deformation of the steel bar. Deformation of a steel bar means you have to calculate the value of P. But it is given the tensile axial strain is 10 to the power of minus 6. So can I write the total deformation of steel is nothing but 10 to the power of minus 6, which is already given. Or it is not a deformation, it is a strain. So strain of steel is this one. So what is the strain value? The strain is nothing but P of steel divided by area into E of steel is equal to 10 to the power of minus 6. 10 to the power of minus 6. Now, P steel you already calculated, which is nothing but P by 4. So can I write P by 4 here? What is the P steel value? Sorry, P steel value is 3P by 4. So this value will be 3P by 4. What is the E steel value? Young's modulus is given as 210 into 10 to the power of 9, which is equal to 10 to the power of minus 6. So 3P value is 840 into 10 to the power of 9 into 10 to the power of minus 6. Area is given as 1 meter square. Okay, so I have taken area is 1 meter square. So from here, you can easily calculate the P value, which is nothing but 240 by 3 is, this will become 3. So this is 280 kilonewton. 280 kilonewton. Okay, that means what you have done in this question, first of all, you have write down the expression for the load. The load which is acting here, it will be balanced by these two forces. Then you have considered the total deformation is 0. Once you know the total deformation is 0, then you will get the relation of aluminum and the steel bar in terms of P. Once you know this value, it is given that the strain value in the steel bar is 10 to the power of minus 6, which is nothing but the tensile strain. What is the strain? You know that strain is nothing but the stress by Young's modulus. What is the stress? The stress is P by A. So same relation I have used here, P by A of steel, and I have taken the steel bar, so you will get the P of steel. So once you know the P of steel, what is the relation of P of steel? 3P by 4. So 3P by 4 means if you put here 3P by 4, so you will get the P value, and that you have to calculate. Okay. Very simple question. The only thing is you have to use the two equation. The first one is the total load which you are applying at the center. It will be balanced by the reaction. And the second is total deformation is equal to 0. Then you will get the load value in terms of this. For example, if you want to calculate, I can make one more question in this one. What is the load which will be carried by the steel and the aluminum? Can you calculate this? Yes. The P of steel and P of aluminum, if I want to calculate, how I will calculate? Because P of steel, you know that 3P by 4. What about P aluminum? P by 4. Because if you add these two, again you will get the P. 3P by 4 plus P by 4 is P only, which is first equation. What is the P value? P value is 280. So if you calculate this, this will become 210 and 280 by 4 is 70. That means they can ask the question. For example, if you know the force value, if you divide with area, you will get the stress. So in any manner, they can form the question. Now, read the option carefully. Why I have discussed this part, if you see, then you will understand. You will appreciate. P value is 280. If you multiply 280 into 3 by 4, which is coming out to be 210. Second thing, if you divide with 280 by 4, you will get the 70. That means they are framing the option in such a manner where the student will do the mistake. They have asked what is the required force, P value you have to calculate, but they have given P of steel also, one of the option, P of aluminum also, one of the option, 70, and this is the final. Raj, can you mute yourself?
Okay, sir.
Okay, so that means whenever they are framing the question, again I'm repeating you, don't finalize the answer until and unless you know that that answer will be correct. Please read the last part of the question where the student will do the mistake. Suppose if you got the steel value 210, yeah, you will verify 210 is one of the option, you will mark. That means they are just giving the option in such a manner the student will do the mistake. They were not asking what is the force in the steel and force in the aluminum. They were asking what is the total force. That is very simple. So if I want to calculate P of steel and P of aluminum, I can make. So the same question I can frame in this format. The load acting at this cross section will be 280. Second option I will give you, the load on steel is 210, load on the aluminum is 70, and fourth I will make load on the steel is 80. So three option will be correct. That means MCQ question can also be framed in MSQ. But the thing is, if you have a thorough understanding how you are solving, how did you get the result, then it is very easy. Okay, so this question was asked in the GATE 2018. This is the question in which the bars are in the straight way. Now, one more question I will discuss in the bar are connected in perpendicular. So this question was asked in GATE 2003. Okay, so what you have to do, you have to calculate the maximum tensile stress. What is the stress? Stress is nothing but this is having a square cross section, means whatever the dimension is this one, same the dimension will be at the back end. Oh, let me check. It is yeah, a bar of varying square cross section. Okay, this is a square cross section symmetrically as shown in figure. Then you have to calculate what will be the stress in first and second bar. Okay, so they have given the four option. Okay, try to attempt. First of all, what you will do, you have to calculate the load on this bar and this bar. So Janesh has given the 25 megapascal. That was one student have given 20. Are you solving this problem, or shall I start? Or if you want
Sir,
more
I
time,
want
just let.
this. I'm confused. It's regarding this. I want you
Okay,
to
what
solve.
about Jagan?
Uh, I couldn't solve too, sir.
Okay, so one student have given the answer. So let's see. See, the problem is simple. The mistake of this problem is where the student will do the mistake. Now see, suppose if you want to take, I have discussed the problem. Okay, but what they have done, they have just rotate this what we call as a bar in the vertical direction. For example, if I will give in this format, no, you can easily solve. The load is acting here. Let us suppose this is 100 kilonewton. This is 100 kilonewton, and this will be 50. I think now you can solve. Because this problem I have discussed. How you will do? You take the section and take the algebraic sum. Take the section, take the algebraic sum. Concept is same. They are twisting the question. Okay, so now see, if you want to calculate the force on this member, that means let us suppose this is 1, this is 2. What is the force on this member 1? 50 kilonewton only, the algebraic sum. What is the force in the member 2? Can anyone please tell me what is the force in member 2?
250.
250. That means the student will do the mistake only here. What they will think, okay, so 100 is acting here, 100 is acting here. So this particular bar is subjected to 100 only. But you know that I have clearly mentioned, if you want to calculate the force on any member, just take the section and take the algebraic sum of load. This 50 will also act here, no? Because this bar is also subjected. So this load also having effect. So what is the total load on this bar? If you take the section here, what is the load? 100, 100 plus 50. But if you take 200, you will get the answer as 20. That is the beauty of this problem. Okay, so P2 value is 250 kilonewton. And problem is very simple, straightforward. So you want to calculate the stress in 150 into 10 to the power of 3. Square cross section. Area is, if this side is 100, then definitely other side will be 100. So 100 into 100. The sigma 2 value is 50. Sorry, sigma 2 value is, this is 1 and this is 2. The P2 load is 215 10 to the power of 3. What is the area? Area is nothing but, sorry, here will be P1 sigma 1 I have taken below 1. No? So this is 50 into 50. And here is 100 into 100. Now, what is this value? This value will be 50 into 50, nothing but 50,000 divided by 2500. So here it will become 20 megapascal. Now here 25 10 to the power of 4, and this is 10 to the power of 4. So what you will get 25 megapascal. But they were asking what is the maximum tensile stress. Maximum tensile stress means out of 20 and 25, which one will be maximum? 20. So the correct answer is 25. If you consider only 200, you will get the some other value. Is it clear, this problem?
Yes, sir.
Yes, sir.
So the only mistake the student will do, they will not consider this particular load. Okay. So even this problem is whatever the problem which I have discussed, I am just considering this is horizontal. They just rotate it in this direction. Okay. So the correct answer for this question is option C. Now the next thing is
Excuse me, sir.
yeah, tell me.
Sir, in this question, sir, in this question, the thing is, now the sir, the bar has been, sir, is being pointed to downwards, sir. Means the forces are here are acting downwards, sir. Then we need to take them as negative, sir, instead of positive.
Which negative? You have to calculate. Let us suppose this is the bar. If you will draw the free body diagram, this particular load will try to elongate this bar or compress this bar.
Sir, this will
bar
try to elongate.
elongate, no? So what I have considered positive only.
Okay, understood, sir.
Okay, now the next thing is one more problem. So I have discussed with the two bars. Let us suppose the three bars are there. That means a rigid bar is there which is supported with the three rod. Then how you will solve these kind of problem? Okay. So I just want to give you one hint for this problem. So there are the three steel bar. Let me check what they have mentioned. Three rod. A rigid bar. This is the bar which is supported by three rods. Okay, three rods of the same material. Okay, this material of this one is same. The area and length of the central rod. Let me write. I think it will be easy. Now see the center portion. The area and length of central rod is, this is 3A. This is L. What about the other two outer rod? 2A and 2L. That means the area is 2A, length is 2L. Here also 2A, 2L. If the downward force of 50 kilonewton, which is applied at the rigid bar, okay, the force in the central and each of the outer rod, okay, that means you have to calculate how much force which is acting on this rod as well as this rod. There are the two options, so four options are given. 16.67 means 16.67 will be acting on these three bar. That means in each means this one is 16.67, 30 kilonewton, 15 kilonewton, 13 kilonewton, 10, 21.4, and 14.3. Okay. Now see how you will solve this particular problem. If you use your common sense, you can easily solve this problem. Okay. That means, see, getting the answer is different, but sometimes you will get to know how to eliminate the option. Now see the option A is 16.67. So if you multiply 16.67, that means one rod having 16.67. If you multiply 16.67 into 3, what is the value? Approximately you will get as 50. Okay, that means this option you cannot eliminate. You have to check the answer. Okay, I am telling you this problem how to solve I will discuss, but how to eliminate the option, that is also a very important thing, because sometimes if you are eliminating the option, it's very easy. Without solving problem you can find the answer. Second thing, if you consider this is 30 kilonewton on the central rod, 15 on the outer rod. So the total rod, let us suppose this is first, this is second, this is third. Can I write the load on first, load on second, load on third is equal to 50 kilonewton? Are you agree with this fact? The total load, whatever the load which is acting on first, second, third, that should be equal to 50. Yes or no?
Yes, sir.
What about Jagan and Janesh? Okay,
Yes,
so
sir.
suppose if I'm asking question, if you are not able to unmute yourself, just mention in the chat box. Okay, so that means the load value P1, P2, P3 value will be equal to 50 kilonewton. Okay, fine. Now, suppose if this is 30 kilonewton, this is 15 in one rod. So another rod will be 15 plus 15. What is this total load? 60. That means this option is wrong. This option itself is wrong. It is contradicting. You are applying the 50 kilonewton load and the load which is supported is 60 kilonewton. Directly eliminate this option. Okay, let's check for other option. This is 30, this is 10. So 10 into, this is one load. That means two load will be 20. So 30 plus 20, 50. This is satisfying. Similarly, 21.4 and 14.3 into 2 is 28 something, 28 point something and 21. It is also. That means without solving without solving this question, you can directly tell which one is wrong. For example, you have very less time to solve this problem. And if you have a doubt on option A and option C is wrong or right, but you can easily eliminate, no, option B is not possible because this is telling 30 kilonewton and 15 into 2 is 30, which is 60. Okay, now try to understand how you will solve this problem. Three rods are there, which is supported this 50 kilonewton load. So can I write, let us suppose the central rod is 2 and I will mention this one is also 1. Why? Because they clearly mention the area as well as the length of this one is same. So I will assume as a 1 bar only. So this is 1, this is 2, this is also 1. Whatever the load which will be carrying by this same load, it will be carrying by other one because both are same only. Young's modulus is same, area is same, length is same, everything is same. Now, can I write this equation? 2 times of P1 plus P2 is equal to 50 kilonewton. First equation. That means P1 load, this P1 load is 2P1 and P2 is equal to 50. Now, the question is you have to calculate what is the load on central, that means P1 and P2. Only you have one equation. Then how you will solve? That means you need one more equation for solving this problem. But if you see the question, when you are applying some particular load and these rods are connected in parallel, suppose if you will apply the 50 kilonewton load, then what will happen? This rigid beam or whatever they have mentioned bar, it will go down. Let us suppose after some times it will be here. But if you see, whatever the deformation of this bar, the same deformation of this bar. So can I equate the deformation? The deformation of first is equal to deformation of second because they are connected in parallel. So if the rigid beam is moving downward, whatever the elongation of this one, for example, after some instant, this bar will be here. This distance for this one, this distance for this one, this distance for this one will be same. So I will equate these two values to get the unknown parameter. So delta 1, you know that P1 into L1 divided by A1 into E1 is equal to P2 into L2 divided by A2 into E2. Now, area is given. Young's modulus is given for this first as well as for second also it is given. Let me take some different groups. For 1 is given, for 2 is given. Okay, so that means in terms of area into length, it will be cancelled out. Young's modulus, it is made up of same material. Okay, there is no issue. So you just consider E. Length value is different. One is whatever the length and area is given. That means you can write down the relation between P1 and P2. P1 can be K times of P2 or P1 can be K times of, P2 can be K times of P1. So you will get the relation between P1 and P2. Once you will put here, P1 is K times of P2, only one unknown is there. you will get the P2 value. Once you know the P2 value, you can calculate the P1. Did you understood how you will approach? Okay, just tell me what is the P1 and P2. Half of the problem, not half of, 70% problem I have solved. Now you have to identify, you have to find what is the P1 value and what is the P2 value. Try to solve. And once you got the answer, so let me know which option will be the correct. And also verify whenever you are getting the answer P1 and P2, it should be matched with the 50 kilonewton. That first equation should be satisfied. Just put in this second equation, whatever the length and area is given, get the relation between P1, P2, put in the first equation, you will get the answer. Do it fast. Anyone got the answer? What is the P1 and P2 value? Which option is correct? Those who got, please mention in the chat box. 30 seconds are left. Do it fast. Very simple. P1, what is the length of first one? This is 2L. Area is 2A. Young's modulus is same, E. What is P2? P2 into L2. What is the length? L. This L. What is the area? 3A into E. So AE will cancel out. This LL will also cancel out. 2 will also cancel out. So you got P1 is equal to P2 by 3. That means, can I write P2 is equal to 3P1? Just put in the first equation. Just put in the first equation. Okay. So if we take P1 plus P2, 2P1 plus P2 is equal to 50 kilonewton. Okay. Now the P2 value you are getting as a 3P1. 3P1. So what is the value of P1? So 2P1, this is 3P1, which is equal to 50. So can I write P1 is equal to 10 kilonewton? If P1 is 10 kilonewton, P2 is how much? 30 kilonewton. Yes or no? So P2 is 30 kilonewton means 30 kilonewton central rod. The load on the central is 30. The outer rod is 10. That means this is 10 and this is 10. So what is this 10 into 10? So 10 plus 10, 20. And this is 30. You are getting the same answer as a 50. That means the total value. So which option will be the correct? The load on the central value will be 30 and the outer value will be 10 kilonewton. So option C will be the correct one. Choice C is the correct one. Is it clear? This question is clear? Jagan, Joshi, as well as Raj.
Understood, sir.
Okay.
Yeah.
So before moving to this particular question, okay, Jen is also understood. Before moving to this particular question, I just want to giving a quick recap of the elastic constant. Okay, and that problem we will solve in the next class because we already have 5 minutes more. So there are the four elastic constant. One is called the Young's modulus. Second is the modulus of rigidity or shear modulus. Third one is the bulk modulus, and fourth is the Poisson's ratio, which is denoted with mu. Okay. What is the Young's modulus? First of all, Young's modulus is the ratio of normal stress to the strain. Normal stress to the normal strain is called as the Young's modulus. So E can be write in terms of stress by longitudinal strain. G value is nothing but the shear stress divided by the shear strain. K value is nothing but which is called as a bulk modulus. Okay, I hope you know these things. This is bulk modulus, this is shear modulus, and E is the Young's modulus. Young's modulus. Gate modulus is nothing but it is the ratio of the hydrostatic state stress divided by the volumetric strain. Okay, basically this bulk modulus is used to calculate the volumetric strain. Hydrostatic means when the stress acting in all the three dimensions are same. For example, if you take the steel ball and dipped in the water, from all the side, if you see only the pressure is active. Okay, that is called as a hydrostatic. Hydro means water. From all the sides, the stress are same. That is called as a hydrostatic. The next one is the Poisson's ratio, which is defined as the ratio of lateral strain to the longitudinal strain. Lateral strain to the longitudinal strain. Okay.
Sir,
Lateral, yeah, tell me, Raj.
just now you have told something about hydrostatic pressure, sir. I missed it. I missed it and didn't understood properly, sir. What is it, sir?
Hydrostatic means, for example, just take this as the cross section. Let's suppose this is the cube. The stress acting in this direction, let us suppose sigma x. Here it is acting sigma y, and here it is acting sigma z. If all these three stresses are equal, that means if I am giving the condition sigma x, sigma y, and sigma z is equal to sigma only. From all the dimension, if the stress value is same, that means all the direction, that sigma x, sigma y, sigma z, if sigma, then it is called as a hydrostatic state of stress. The best example is if you take the steel ball and dipped in the water. So from all the sides, the pressure which is acting, compressive force, which is nothing but the pressure, from all the sides, the pressure will be same. Okay, that is the meaning of hydrostatic. Hydro means water, static means at the rest condition. So if sigma x numerically, if sigma y and sigma z, if it is given same, then it is called as a hydrostatic stress condition. Okay. Now,
Okay, sir. Means
yeah, tell me.
Here, here the stress acting in both directions should be same.
Stress in not both, in all the three. Both means two only.
All the directions, sir. I mean, if the stress, if stress is acting on all directions of the body or in all dimensions are equal, then it is hydrostatic stress.
Hydrostatic stress. Okay. Clear?
Clear, sir.
Mention also here sigma x, sigma y, sigma z is equal to sigma. That is the condition of hydrostatic state of stress. Now it comes to the Poisson's ratio.
And one
What
more
do you
thing,
mean by?
sir.
Yeah.
Sir, this Young's modulus is ratio of. Yes, sir. This Young's modulus is Ratio of what's the stress to longitudinal strain?
Normal stress to the longitudinal strain. Let us suppose this is the rod. The force is acting here. This is the normal load. No, what the stress will develop? The normal stress is nothing but P by A. If you want, you can write down sigma n. Normal stress to the longitudinal strain. This is shear stress to the shear strain. This is what we called as a, either you can take as an average stress or sigma also, because average stress is nothing but, you know, that average stress in this case, sigma x plus sigma y plus sigma z divided by 3. What is this value? All are equal. So if you add, then you will get 3 sigma by 3, which is nothing but sigma. That's why I have mentioned here sigma. So the bulk modulus is the stress value sigma, hydrostatic stress, divided by volumetric strain. This is normal stress to the longitudinal strain. This is shear stress to the shear strain. Then the next one is Poisson's ratio. This is lateral to the longitudinal. I hope these things you already know. These are very basic things. I hope you attended my live classes also. Is it clear now? Did you
What, sir? I
understood the
didn't
term?
get you.
Sorry,
I didn't get you, sir.
which one you didn't understood?
Just now you have
Sorry.
told something regarding these formulas.
This is normal stress. This is longitudinal stress. Normal stress. What do you mean by normal stress? What is the meaning of normal stress? Normal load per unit area, no? Normal load per unit area is the
Yes, sir.
normal stress. Longitudinal strain means the strain developed in the this direction. Longitudinal strain means change in length by original length. What is the shear modulus? Shear strain, shear stress to the shear strain. Bulk modulus is sigma by volumetric strain. Then mu is the ratio of lateral to the longitudinal. If you are not revising properly, no, then the mistake will happen. Okay, I will explain the longitudinal and lateral also. Let us suppose this is the load. If you are applying the load, what will happen? This rod will elongate. What will happen? The length value will increase. The diameter is decreasing. So the stress which is the strain which is developed in the direction of load, that is called as a longitudinal strain. What is longitudinal strain? Change in length. Let us suppose the original length is L naught. Original length is L naught. Let me take the same color. And the diameter is D naught. Okay. So change in length by original length is nothing but the longitudinal strain in the direction of load. What is this value? Change in length means L naught, L minus L naught, because the final length is LF divided by original length, which is L naught. So change in length by original length is longitudinal in the direction of applied load. Suppose if one length is increasing, other dimension will decrease, no? Other dimension is decreasing means the lateral strain. Change in diameter to the original diameter. So the final diameter is df and the original diameter is d naught. So d naught minus df divided by original diameter is nothing but the lateral strain. So what is the lateral strain and longitudinal? Longitudinal means the strain developed in the direction of applied load, change in length divided by original length. Lateral strain is change in diameter to the original diameter, means the strain developed in the perpendicular direction of the applied load. That means delta d by d naught. Okay. So if you write down the ratio of this lateral to the longitudinal, then you will get the Poisson's ratio, which is nothing but lateral strain to the longitudinal strain. Lateral to the longitudinal strain. So there are the 4 elastic constant. And what will be the relation on this 4 elastic constant, that I will discuss in the next class, will be on 11:30. Okay.